Undervoltage protection function test in MiCOM P141 relay. Voltage collapse occurs for various reasons, such as increasing network load, decrease in phase voltage due to fault in the network, complete loss of bus voltage, and similar cases. So protection 27 is intended for different equipment. Suppose that in the MiCOM P141 relay, there is AND logic through which the relay measures the phase to ground voltage and has a three-phase operation logic. The test preparation process will begin, provided that the setting at 51 volt phase to ground with a time of 4 seconds is provided for the relay. First of all, take a look at the relay configuration during AM Pro settings to be aware of the conditions that may have blocked an operation of the undervoltage function. For example, as you can see here, opening the breaker or disconnector blocks the undervoltage. As another example with online monitoring using Monitor DDB Signals feature, you also find that VTS blocks function 27 with AND logic when only one of the voltage phase is off. Note that if no conditions has prevented its operation, by default a tripping command is issued by it, and therefore the tripping contact is active. For this reason, it is necessary to create state 1 by default with nominal values to get the relay out of it and ready to test. Since the current supervision function is not active, there is no need to inject current in the relay. Therefore, deactivate the current outputs in hardware configuration. You can specify the end condition of this state on a time or pressing a space key in order to manage time duration. Create the next state to make pickup conditions in 3 phases. Here you can select continuous ramp or step ramp in a state type to reduce 3-phase voltage simultaneously. The difference between these two state types has already been explained in the following videos, but briefly it can be said that the values are steadily increasing in continuous ramp and the decrease with the specific steps by the user in a step ramp. The step ramp is selected here. In a start value, start voltage values of the state remain by default, but in order to speed up the test, you can select a value close to the operation settings. Since the constant time characteristic requires 4 seconds to display its performance, it's needed to make it even a little longer after each voltage change. Therefore, a step time is set to more than 4 seconds, for example 4.5 seconds. Another solution is to change the amount of time in the relay from 4 seconds to 0 and perform the test faster. So you can set the step time to a little value such as 200 milliseconds. In a step values, specify the value of the voltage reduction step. The smaller the steps, the more accurate the pickup value obtained, but it takes a long time. Finally, the final value is specified in final values because the voltage is set to 50 volts in the relay setting. This value is set to a less value, for example 45 volts. Afterwards, in trigger, you should specify under what conditions this state ends. If a specific LED is determined to record the relay pickup, you can select a space key press option and press the space key while the LED is on. By referring to the MiCOM relay PSL, it's defined LED 1 with any start input to turn on if any element is picked up. At this stage, this option can be used to detect pickups. Dealing with it, you can assign a contact to the relay pickup. In this case, you can select the use binary trigger condition as specified below option in trigger. For example, record the pickup time by connecting the output of the relay contact to the default binary input C1. In the next step, form the drop-off process in the same way, but with the process of increasing the voltage. The step ramp is also selected here. The start value is lower than the setting value, for example, 45 volts. Keep in mind that depending on the moment of the drop-off process, you can set step time to a low value such as 500 milliseconds. In a step value, into the value of 200 millivolts, and in the final step section, the nominal value remains the same. In trigger, you can select the space key or changing a binary from 1 to 0 as a state termination of drop-off state. Finally, the operating time is recorded. It is highly recommended to first create a state for pre-fault to return the condition to normal again. The state trigger is a time or space key press as you wish. Now in the final state, to measure the operating time, set the state type to normal mode with a voltage below the operating limit for 3-phase. This state trigger can also be relay tripping contact, which is assigned to one of the binary inputs by default. Or it can be recorded by pressing a space when it sees the relay LED. However, due to the high accuracy, it's recommended to use binary status change. At the end of the test, it's time to apply the settings to record the values in the measurement view. First, enter the name, ramp status, state completion condition, signal to be checked, signal type, nominal value and tolerance for the state in which the pickup is registered, that is state 2. If the values are entered correctly, you will see the amount of voltage recorded for the 3-phase pickup in the ACT column. Also in DEV, the recorded error, and in the assessment section, green confirms the test results. Follow this for the state in which drop-off is recorded. You can now record the operating time assessment in Time Assessment. Here you also enter the state name, states or conditions that should be ignored in this review, start and end conditions, nominal value and tolerance limit. In this section, if all the items are entered correctly, you can see the operating time in TACT column. Also, the errors are specified in TDEV, and you can make sure of the correct operation in the assessment. After this step, by selecting parameters and then clicking on Reports, you can select the elements that you want to display in report settings and have the output as a file.